PLI stands for Production Linked Incentive, a scheme that aims to give companies incentives on incremental sales from products manufactured in domestic units. PLI can also refer to Power Line Instruction, a communication protocol that sends control instructions to luminaires over the standard power wires. However, in this video, we will focus on the former meaning of PLI and how it can be used for critical parts and reverse engineering industrial labs. Critical parts are components that are essential for the functioning of a product or system, and that are difficult to replace or repair. Reverse engineering is the process of analyzing an existing product or system to understand how it works and how it can be replicated or improved. Industrial labs are facilities where reverse engineering can be performed using various tools and techniques. In this section, we will show you how to set up and operate a PLI system for different types of parts and materials. We will cover the following steps. Identify the critical part that you want to manufacture locally using PLI incentives. For example, you may want to produce a part that is imported from abroad, has a high demand, or has a strategic value. Analyze the critical part using reverse engineering methods, such as scanning, measuring, testing, and modeling. You can use industrial labs that have specialized equipment and software for this purpose. The goal is to obtain the geometry, dimensions, material properties, and functionality of the part. Design and optimize the manufacturing process for the critical part using CAD/CAM/CIM software. You can use simulation and analysis tools to evaluate different parameters, such as cost, quality, time, and environmental impact. You can also apply design for manufacturing principles to reduce waste and complexity. Select the appropriate rapid prototyping technique to create a physical prototype of the critical part. You can use methods such as 3D printing, CNC machining, injection molding, or casting, depending on the material and geometry of the part. The prototype should be tested and validated for performance and reliability. Scale up the production of the critical part using PLI incentives. You can apply for PLI schemes that offer financial benefits based on incremental sales from products manufactured in domestic units. You can also leverage PLI schemes that focus on cutting-edge product groups where India has no manufacturing capabilities. Monitor and improve the quality and efficiency of the production process using coordinate metrology. You can use instruments such as coordinate measuring machines, CMMs, laser scanners, optical sensors, or vision systems to measure and inspect the critical parts. You can also use statistical process control, SPC, techniques to detect and correct any deviations or defects. By following these steps, you can set up and operate a PLI system for different types of parts and materials. This will help you to reduce dependence on imported machinery, increase competitiveness in global markets, and contribute to economic growth and innovation. In this section, we will learn how to analyze and interpret the PLI data and use it for quality control, defect detection, or design improvement. PLI stands for Production Linked Incentive, which is a scheme that provides incentives to manufacturers for producing certain products or components that are critical for the economy or the environment. PLI data refers to the information that is collected and reported by the manufacturers who participate in the scheme. The first step in analyzing and interpreting PLI data is to examine each component of the data in order to draw conclusions. Do you notice any patterns or trends? Can you see any errors or inconsistencies? For example, you can look at the PLI data for clean energy technology and see how much incentive was given to different manufacturers, what kind of products or components they produced, and how much they contributed to reducing carbon emissions. The second step is to explain what these findings mean in the given context. What does this mean for your reader? What story is the data telling? For example, you can interpret the PLI data for clean energy technology and say that it shows that the scheme was successful in promoting local production of critical components such as solar panels, batteries, and wind turbines, and that it helped India become more competitive and sustainable in the global market. The third step is to present the data in a way that helps your reader use the information for their purpose. Which findings are most relevant or important? Will text or graphics make meaning clearer to your reader? For example, you can present the PLI data for clean energy technology using tables, charts, or graphs that highlight the key figures and comparisons, and use captions, labels, or annotations to explain them. By following these 3 steps, you can analyze and interpret PLI data and use it for quality control, defect detection, or design improvement. Quality control means ensuring that the products or components meet the standards and specifications required by the scheme. Defect detection means identifying and correcting any problems or errors that may affect the performance or safety of the products or components. Design improvement means enhancing or modifying the features or functions of the products or components to make them more efficient, effective, or innovative. To summarize, analyzing and interpreting PLI data involves examining, explaining, and presenting the data in a logical and meaningful way. This can help you understand how the scheme works, what benefits it brings, and what challenges it faces. It can also help you make recommendations for improving the scheme or applying it to other sectors or products.